Hello everyone, my name is Shekhar. I am from Department of Information Technology. Today I am going to explain a topic from subject called Design and Analysis of Algorithms. And our first slide is the title. Okay, the title is Quick Sort: Unexpected Speed Up in Java on Multiprocessors. Okay, and our first and the let us go into the topic. Introduction of quicksort. Okay, sorting is a fundamental operation in computer science and is widely used in databases and systems. Quicksort is one of the most efficient and commonly used sorting algorithms. With the rise of multiprocess systems, understanding algorithm performance in parallel environments is important. Okay, let us check the once again introduction. What is going to discussed in this session means sorting is a fundamental operation in computer science and widely used, and how the quicksort will be worked in efficiently we are going to see. And with the rise of multiprocess systems, understanding the algorithms are very important. Okay, and our next slide is design and analysis of algorithms. Okay, what is design and analysis of algorithms means? Design of algorithm focuses on creating efficient solution for computational problems, and analysis of algorithms evaluates performance using metrics such as time complexity, space complexity, and scalability. Okay, and algorithm performances can vary significantly depending on hardware architecture and execution environment. Okay, design of algorithm focus on creating efficient solution for computational problems, and analysis of algorithms is based on the three types. The first one is time complexity and space complexity and scalability of the algorithm. Based on these aspects, we decide whether the algorithm is most efficient or not, and we use the efficient algorithm based on the requirement. For example, we need a space, we use space complexity less space complexity algorithm. If we need the faster one, we will consider the time complexity algorithm. Based on the requirement, we change the or we adapt the different type of algorithm. Okay, and our next slide is overview of quicksort. Okay, quicksort is divide and conquer algorithm that recursively partitions an array around a pivot element. It achieves an average time complexity of big O of n log n, making it one of the fastest comparison-based sorting algorithms. Despite a worst complexity of big O of n square, good pivot selection ensures efficient performance in practice. And as we know, as I said, analysis of algorithm based on three aspects. First one is time complexity, and second one is space complexity, and third one is scalability. Here we can see the time complexity of the quicksort algorithm is big O of n log n, and in the average case, in the worst case, big O of n square. For the quick algorithm for quick sorting, we use quicksort algorithm to solve the in order to solve the problems. And our next slide is quicksort mechanism. Quicksort working mechanism. How the quicksort will work means the algorithm selects a pivot and rearranges elements to the smaller elements are placed before the pivot. Larger elements are placed after the pivot, creating two independent subproblems. And these subarrays are recursively sorted until the entire array becomes ordered, which means the goal is to make the array sorted. Okay, first it will select the pivot and rearrange the elements so that the smaller elements are placed before the pivot, and the larger elements will comes after the pivot element. This will be recursively solved until the entire array becomes ordered or sorted. And quicksort implementation in Java. How the quicksort will be implemented in Java means Java sorting libraries are use highly optimized variants of quicksort for primitive data types. Java benefits from automatic memory management and efficient object handling. The Java runtime environment enhances performance through internal optimizations. Okay, this is how the quicksort will be implemented in Java. It will be inbuilt in libraries so that the users can be used inbuilt. And multiprocessor systems. How what is multiprocessor systems means? Multiprocessor systems consist of multiple processing units that execute tasks simultaneously. Such systems allow parallel execution of independent computations. Modern CPUs use multiple cores to improve throughput and reduce execution time. Okay, which means multiprocessor systems consist of multiple processing units and that executes tasks simultaneously. Such systems allow parallel execution of independent computations. Okay, how the multiprocessor systems will work means like this. Okay, and parallelization of quicksort. Okay, quicksort is naturally suited for parallel execution because of its subarrays are independent. Different processes can sort different partitions at the same time. This parallel approach significantly reduces the total sorting time compared to sequential execution. That's why the quicksort algorithm have the big O of in login, which is very quick to sort the algorithms. The main reason is the subarrays are independent and different processes can sort different partitions at the same time, and this approach will reduce the overall sorting time. And our next slide is concept of speed up. Okay, unexpected speed up. Our title is, we know that unexpected speed up in Java by the quicksort algorithm means speed up refers to the improvement in execution time when using multiple processors instead of one. Okay, and ideally speed up is proportional to the number of processors used. However, real-time systems often expensive deviations due to overhead and hardware effects. Okay, uh, speed up is directly proportional to multiple processors, and speed up to increase in order to increase the speed we have to use multiple processors instead of one. Okay, and our next slide is unexpected speed up phenomenon. Okay, the study observed speed ups greater than what theoretically model predicted. Performance gains exceeded the expected benefits of parallelism alone. This behavior indicated the presence of additional optimization effects. Okay, and our next slide is cache behavior and memory effects. Parallel execution improved cache locality by working on smaller subarrays. Reduced cache misses resulted in faster memory access. Better utilization of CPU cache contributed significantly to the speed. And our next slide is role of Java Virtual Machine. Okay, JVM. We can call it as JVM. Okay, the JVM uses JIT, which means just in time compilation to optimize frequently executed code. Runtime profiling allows the JVM to apply aggressive optimizations. These optimizations improve execution speed, especially in parallel programs. Okay, and our next slide is experimental analysis. How the quicksort is experimentally analysis means experiments conducted on multiple processes with different core counts. Performance measurements showed consistently improvement with more processors. Results confirmed that Java quicksort scales efficiently on multi-core systems. Okay, how the experimental analysis gone means experiments were conducted on multiple processor machines with different core counts. We increased the core counts and experimented by using the quicksort and quicksort of multiple processor machines, and performance measurement shows consistency improvement with more process, and the results are confirmed that Java quicksort scales efficiently on multiple core systems, has improved performance of the overall system. And our next slide is conclusion. In conclusion, we can say that Quicksort demonstrates excellent scalability when implemented in Java on multi-processor systems. Unexpected unexpected speed up occurs due to cache efficiency, JVM optimizations, and parallel execution. This study highlights the importance of considering system architecture in algorithm analysis. Um, what the in conclusion we can say that which means the quicksort by using the quicksort implemented in Java and multiprocessor systems, the unexpected speed up occurs due to cache efficiency and JVM optimizations and parallel execution, since the quicksort subarrays are independent so that it can executed by the different process at the same time. By this, the system overall system performance is improved, and this is the final slide. Okay, thank you. I hope you understand the session. Thank you. Thank you.